In this video, we will do problems from exercise 6.8. Question number 1. Show that the straight lines r is equal to 5i cap plus 7j cap minus 3k cap plus s into 4i cap plus 4j cap minus 5k cap, and r is equal to, which is given by this vector line or coplanar. Find the vector equation of the plane in which they lie. So let us define, let a vector be this, let this be our a vector, 5i cap plus 7j cap minus 3k cap. So this is the position vector of the point which lies on the straight line, which is given by this equation. Then vector b is the line which is parallel to this line, and which is this 4i cap plus 4j cap minus 5k cap. Similarly, for line 2, you have this as the position vector of the point which is on the line, which is, we can define that as vector c is equal to 8i cap plus 4j cap plus 5k cap. Similarly, this will be the line parallel to this vector which will be parallel to this line. So vector d can be defined as 7i cap plus j cap plus 3k cap. Now we know that the condition for the two lines to be coplanar is c minus a dot product with b vector cross product with d vector is equal to 0. So this is the condition. So let's find our c minus a vector and b cross product with d vector. So let's find what is b cross product with d vector. So that is given by I cap, j cap, k cap. Coefficients of I cap, j cap, k cap for b is 4 minus 5. Similarly for d it is 7, 1 and 3. So further simplifying this, you can say this is I cap into 12 plus 5 minus j cap into 12 plus 35 plus k cap into 4 minus 28. So simplifying this further, we get 17 I cap 47, so minus 47 j cap, and this will be 24 minus 24 minus 24 k cap. Similarly, our c vector minus a vector is equal to c minus a is 8 minus 3, which is 8 minus 5, which is 3 I cap, 4 minus 7, which is minus 3 j cap, then 5 minus 3 will be plus 8 k cap. Right. So now our condition, which is c minus a vector dot product with b cross product with b is equal to, so let's put the values, 3 I cap minus 3j cap plus 8k cap into 17 I cap dot product here minus 47 j cap minus 24 k cap. So further simplifying this, we get the answer to be 51 plus 141 minus 192, and that's equal to 0. Therefore, the two given lines are coplanar. Let's go to the second part of the question, which is find the vector equation of the plane in which they lie. So, since you're given the lines in the coplanar and they are coplanar, so the non-parametric vector equation is R vector minus A vector dot product with V cross product with D is equal to 0. So, replacing the corresponding values, we get R vector, or we can rearrange this as R vector dot product with B vector cross product with D vector is equal to A vector dot product with V cross product with D, which is using the distributive law, further expanding and then taking the A dot product with B cross product with D to the other side. So, now let's replace the values here. So, our R vector dot product with B cross D is 17 I cap minus 47 j cap minus 24 k cap is equal to A vector is given by 5 I cap plus 7 j cap minus 3 k cap dot product with 17 I cap minus 47 j cap minus 24 k cap. So, further simplifying the right hand side here, this will be 85 minus 329 plus 72. So, simplifying this is equal to minus 172. Therefore, our equation is R vector dot product with 17 I cap minus 47 j cap minus 24 k cap is equal to minus 172. Question number 2. Show that the lines x minus 2 by 1 is equal to y minus 3 by 1 is equal to z minus 4 by 3 and the line x minus 1 by minus 3 equal to y minus 4 by 2 equal to z minus 5 by 1 are coplanar. Also find the plane containing these lines. Let's define our x1, y1, z1 equal to 2 minus 3, 2, 3 and 4. 2, 3 and 4. Similarly, let b1, b2, b3 be equal to 1, 1 and 3. Then let's also define our x2, y2, z2 as 1, 4 and 5. 1, 4 and 5, and our d1, d2, d3, which are the direction cosines of this line, as minus 3, 2 and 1. Now the condition for coplanarity is given by the determinant x2 minus x1, y2 minus y1, z2 minus z1, b1, b2, b3, d1, d2, d3 is equal to 0. So let's replace all our x2, x1, b1 and so on with our actual values. So the left hand side here would be x2 minus x1 is 1 minus 2, which is minus 1. Similarly, y2 minus y1 will be 1, 1. Then our b1, b2, b3 is 1, 1 and 3. And our d1, d2, d3 is minus 3, 2 and 1. So further solving this, you get minus 1 into 1 minus 6 minus 1 into 1 plus 9 and plus 1 into 2 plus 3. So that's equal to, this is minus 5 into minus 1, so plus 5. 10 into minus 1, minus 10. 5 into 1 is plus 5, which is equal to 0. Therefore, the given lines are coplanar. Now for the Cartesian equation of this, it can be x minus x1, y minus y1, z minus z1, b1, b2, b3, b1, b2, b3 is equal to 0. So this is the Cartesian equation of the plane, which contains these two lines. So simplifying this and substituting the values, you get x minus, our x1 is 2, minus 2, then y minus 3, z minus 4, 1, 1, 3, then minus 3, 2, 1 is equal to 0. Further simplifying this, you get, I'm going to start from here, x minus 2 into 1 minus 6 minus y minus 3 into 1 plus 9 plus z minus 4 into 2 plus 3 is equal to 0. So simplifying this further, you get minus 5x plus 10 minus 10y plus 30 plus 5z minus 20 is equal to 0. So simplifying this further, you get minus 5x minus 10y plus 5z plus 20 is equal to 0. So further, you can divide it by 5 with a minus 5 actually. So your answer would be x plus 2y minus z minus 4 is equal to 0. That's our answer.
Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.